that's part of my PhD that I did at the molecular college lab at Flinders University under the supervision of Luciano. And okay, so I swear I had this slide on before GX Sites mentioned this yesterday, but there are some known shortfalls in biodiversity conservation, which are the linear shortfall in relation to the lack of knowledge in taxonomy, the Wallacean shortfall in relation of our lack of knowledge about the distribution of species, and the Darwinian shortfall, which is like we don't know about the phylogenetic relationship of many species around the world. And those shortfalls are accentuated in the Neotropical region, especially because of the high biodiversity and remoteness of several regions. So it's hard to go out there, it's hard to find species, and it's hard to just do field work in several places in the Neotropics. As I said, I work on Cerrado lizards. The Cerrado is here. It's central in South America, surrounded by Amazonia and the Caatinga and the Atlantic forest, Chaco, Pantanal. So it's pretty much in the middle of all major biomes of South America. It is one of the formally recognized world's biodiversity hotspots. It's the only tropical savanna in the list, and it's a very, very threatened biome. So only 2.2% of its territory is under legal protection, and every year deforestation rates increase. So in relation to Cerrado herbs, it was initially considered impoverished in comparison with surrounding biomes, so it was even proposed that the diversity of the Cerrado would come from the surrounding biomes, like the Amazon and the Atlantic forest. But this has been changing since the early 2000s, and it was proposed that the low diversity was actually an artifact of modest collection efforts. And the last big compilation that we have on Cerrado reptiles is from 2011. And we had like 267 reptiles in the list. 103 of them are endemics, which is quite high, including 32 endemic lizards, which account for 42% of the species of lizards in the biome. So there are still many lizard species being described every year, and we know that using morphology only, you can't assess the whole biodiversity of the biome. And one good thing about working on species delimitation is that you have the potential to confront all the three shortfalls at once. So you find new species, you know the distribution, and you infer phylogenetic relationships. Here are just some examples of new cryptic lizard clades described for the Cerrado in the last 3 years. So this is with Philopezus, and where several new clades were recovered. This one is with Ameiva, which actually has a description of a new species. And this one from the last year is with Panzosauda, those nice looking little lizards that ended up with the distinction of 3 different species. And I work on 3 endemic lizards from the Cerrado, Micrablepharos aticulus, Genomics amarali, and Tropidurus itamberê. They all are widely distributed in the biome, and as I said, they all are endemic to the Cerrado. Okay, this figure looks horrible, but PCs. We previously reported 8 cryptic species in Genomics amarali using only 2 loci and morphology. And this is just to let you know why we think there might be cryptic species in my 3 taxa. And in the case of Genomics amarali, we actually know there are. In the case of Micrablepharos aticulus, there is this paper from last year as well showing deep divergence clades using only mitochondrial DNA, but they didn't assess like cryptic diversity. And for Tropidurus itamberê is probably the most problematic species that I'm working with. I know there is great morphological variation between populations because I've been out there and collecting the lizards and I can see they're completely different. But there is a big problem with Tropidurus taxonomy as a whole. One of the reasons, in my opinion, is that we've been using mic pockets, which is this little thing here. Torpedoes have mic pockets in the necks and under the arm and close to the posterior limb as well. And there's great variation in the size and in how deep those mic pockets are. And this, pretty much everyone working on Torpedoes taxonomy have been using mic pockets. And I guess the use of this character is probably the reason why taxonomy is so confusing in the genus. And I also know that for my species, there are great variation in anterior posterior limb lengths, which I believe are specialization for the use of rock crevices. Okay, so there's no morphological and genetic differences between populations of all my species that could reflect species level divergence. So the main of this particular talk is to clarify putative cryptic diversity within each of my species.
Try pointing it at the computer.
Okay, so just to quickly show you, this is portion map of Brazil. The orange outline is the distribution of the Cerrado biome. And I had 170 Genomics amarali distributed, they mainly distributed in the northern portion of the biome. 139 Neotropics atípicos distributed everywhere. And 103 Torpedoes também. I initially used mitochondrial DNA, so, and based on the topology of the mitochondrial DNA tree, I selected a subset of samples to use an anchor-phylogenomic method described by Lemon and collaborators in 2012, which gave me around 400 loci for each species. And using these anchored phylogenomic data sets, I did concatenated phylogenetic analysis, maximum likelihood and Bayesian, usual stuff, and also Coalescent species trees using STAR and NHS. And those two, they use gene trees to actually build the Coalescent species trees, to infer the Coalescent species trees, which I generated using RexML as well. And the main focus of the talk is I use BPP version 3, a Bayesian Coalescent species delimitation approach, to actually infer species boundaries. And BPP version 3 also estimates the species trees. So if you use to BPP, you know that version 2 used the fixed topology, and what it did is it used a reversible jump algorithm to change this topology. So if you had like species A and B here, what it did was pretty much to collapse the nodes. So you have A, B as one species here, and another option of all species collapsed in one node. And the main difference between BPP 2 and 3 is that in 3 the topology can change. So the problem with BPP 2 is that if you have a fixed topology and this topology is wrong, you probably, your species delimitation is wrong. So to try and solve this issue, Young and Renala, they published BPP version 3 in 2014, and now it uses this nearest neighbor interchange algorithm to change the species tree. So you can, at the same time that you're inferring species boundaries, doing your species delimitation analysis, you're also inferring a species tree, right? These are quickly showing my results for Genomics amaralis. So I had 12 different groups, which I selected based on being monophyletic groups and in the geographic distribution. For all my species, the Bayesian and the maximum likelihood analysis gave me the exact same topology, which was just slightly different from the Coalescent species trees. So 12 groups for Genomics amarali, and I had 9 for Megablephus articulus. As I said, the same thing, Bayesian and maximum likelihood are exactly the same, just slightly different from the Coalescent species trees. And the same for Torpedoes também, which I had like 5 different groups. So those were the groups that I used in the BPP analysis to infer, like to run the species delimitation analysis, right? And I'd just like to point out two morphology, like two Tropidurus and Tamberé that are outside the main group. And this I collected myself in the field, and you look at them, they're exactly the same, like the Tropidurus and Tamberé, considering the morphological characters that we have nowadays to distinguish those species. But they actually nested within my outgroup, so of course they were not included in the species delimitation analysis. Okay, for Gymnodactylus amarali, I had 9 well-supported species. And when you run in BPP, you can use your ambiguous sites in the analysis to calculate the likelihood, or you can just use the clean data, which is excluding all the ambiguous characters from your analysis. And I had slightly different results considering using both algorithms that BPP has, and also using the ambiguous sites or excluding the ambiguous sites. The same pattern for Microblephalus articulus for 8 well-supported species, and for Tropidurus and Tamberé, it's the clear pattern that I had, so all species were well-supported during all the runs and etc. This was just something slightly interesting. So, for example, one of my supported species using DPP is actually a paraphyletic species, considering the other species trees in the concatenated analysis. And the same pattern I found for Microblephalus, which F and G were together in one species. As far as I know, there are 2 papers using DPP version 3 out there, both on lizards. This one you guys probably saw Adam's talk the other day. So I would just like to point out that for the shorter branch that they had, those numbers here are the BPP posterior probability, and it was exactly the one where they had like the smallest posterior probability. And the other paper published did find paraphyletic species, but did not discuss the issue. So it's this one here, and also in a very short branch. So why the BPP species tree are so different from the other trees? I don't know. I think it's a problem with the short branches. So even with such a powerful data set, the actual delimitation of my species turned out to be challenging. I had this paraphyletic species, which doesn't mean they paraphyletic, it's just like the species tree that DPP estimates is completely different from the other species trees. And I had also slightly different results from the different algorithms and using or not ambiguous sites, which I think it's a problem with mixing. And okay, so BPP species delimitation is well tested, everyone knows that, but the species tree algorithm is not. So I don't know, maybe problems with gene flow. If you saw Brian Costin's talk yesterday, you know that might be problematic. So just would like to let you know that this is part of a comparative phylogeography project, and I'm also testing several diversification hypotheses within the Cerrado biome using the same data set. And take-home messages are, I have many cryptic species, and BPP version 3 species delimitation estimation gives different results from other approaches, and I think more empirical tests are still needed. I would like to thank my sponsors, Capis, and everyone at the Molecular Ecology Lab at Flinders, everyone at the Molecular Protection at the University of Brasilia, and thank you very much for your attention.